I wanted to do experiments with sensors, and then especially infrared sensors, etc., etc. I did the first few experiments, but well, I thought perhaps it's a good idea to make a bunch of LEDs, light emitting diodes, that stray out all kinds of frequencies in the visible spectrum and in the invisible spectrum. So that's what this video is all about. Here is my box with sensors. Well, I have already made a very first video about this anyway. I had to study it all over again, and perhaps interesting that I in the past bought a infrared diode. It's now obsolete, but anyway. And in the data sheet I could find that this worked on approximately between 920 nanometer and 1000 nanometer, and the peak it was on 950 nanometer. That's always the thing that you see when you study LEDs, their frequency, where they stray out light, visible light or invisible light. And for instance, here I found on the World Wide Web, this is the spectrum of a warm white LED. I have taken it over, I didn't control it. Of course I know that not all white LEDs are the same. There are also cool white LEDs. So that means that the cool white LED has another, in general, I have to study that, a somewhat other spectrum. Here you see the wavelengths, 400 nanometer up to 700 nanometer. This is daylight. It has a much broader spectrum, especially in the violet range and the blue range. So anyway, I want to make a switch with say 6 positions or 7. That depends on the amount of LEDs that I want to use. And then bunch all these lights, these LEDs together, make a bundle, and then a 6 position or 8 position switch. Here again that infrared diode, here a red LED diode. It's out of a computer mouse. The frequency must be somewhere between 650 and 700 nanometer. The peak, where there is a peak, it's unknown, but there's surely a peak. And say the red light goes a little bit alongside with the infrared light. Of course the frequency differ a lot, but anyway. And the frequencies that I show here are the values from the theory that I found on the World Wide Web, etc., etc. Yellow LED 565 up to 590 nanometer. Orange LED. Tested them first, of course, and where you see this, that means that is the positive lead. All these LEDs can be say supplied via a 1K resistor, though it's very important that every LED in fact needs its own resistor to be supplied out of a voltage and current source. Because say the amount of light differs, and could be that when you don't take the resistor, the right resistor, the critical resistor, the LED can burn out, but that's tiny risk, because with a 1K resistor on 12 volts it always goes good. Blue LED, this is the frequency range. The white LED, I've showed the frequency range here and told about it. So here again some things that I studied today, found out today. visible light spectrum, and I have to say that on other sources, this is from Salt Co. Website on the World Wide Web. On other sources they differ somewhat, and of course this is fluid. The whole say color range, frequency range is fluid, and often there are no precise definitions for certain colors. So what is yellow? Well, as far as I know, we know in general how yellow looks like, but in scientific terms that makes in a certain way no sense, because there is a certain frequency band for that color. Infrared, this is what I found on the World Wide Web, and that was all. Thanks for watching.